All right, let's take a look at number 11. We're going to use the formula for the sum of a geometric series to find the sum of this series here. Now, it looks a little strange. I'll just remind you, of course, they tell you it's a geometric series, and on the test, I give you the summary of tests for series. There's the geometric series. We know it is convergent if the absolute value of r is less than 1, where r is that fixed ratio that we're multiplying by each time to get the next term in the series. If the absolute value of r is greater than or equal to 1, then the series will be divergent. The sum is not going to be finite, and therefore you can't use this sum formula, by the way. This sum formula only works for, for convergent series. So we first need to ascertain that this series is convergent or not, and then if so, of course, we can find the sum. So I'm just going to start. Notice it's starting with n equal 9, and that's okay, right? N, you can start anywhere, 1, 0, 2, 5, or 9. And we just start the first term then is when n is 9, right? If I plug in 9, 6 times 9 is 54. 56 minus 54, I get e squared. There's n equals 9. If I plug in 10, then I get 56 minus 60, I get e to the negative 4. If I plug in 11, 56 minus 66, e to the negative 10. And then when I plug in 12, I get this. And you can basically see each time the exponent is going down on the base e by 6. The first term in the series obviously is e squared. So it's geometric. What am I multiplying by? If the exponent is going down by 6 each time, I've got to be multiplying by e to the negative 6. Because remember, when we multiply like bases, what do? We add the exponents. So e squared times e to the negative 6 will be e to the 2 plus negative 6, or e to the negative 4. If I multiply e to the negative 4 by e to the negative 6, adding negative 4 to negative 6 gives me negative 10, and so on. So this is what I'm multiplying by, which is just 1 over e to the 6th power. Right? And clearly this is less than 1, right? E to the 6 is a humongous number. 1 divided by that is going to be something less than 1. So the absolute value of r is less than 1, and we know the series converges. So now I can use that sum formula. In my sheet, I've got c for the first term instead of what I'm calling a, the first term here. Same idea though. So a or c over 1 minus r. The first term in the series is e squared. The value of r is this. I write it in this form because they want the end result, right, in fraction form, symbolic notation of fraction form. So I don't want to have the negative exponent there. I want to put it in fraction form. And the best way to me to clean up this compound fraction is multiply by e to the 6th. Of course, I have to do that same to the top and bottom to write an equivalent fraction, right? Multiplying by 1. E squared times e to the 6th, add the exponents e to the 8th. And then here I need to make sure I distribute e to the 6th over the 1, and then e to the 6th times 1 over e to the 6th obviously is just 1. And there is your sum in exact value. Okay, hope this one helps. Hope this helps. This is a kind of interesting one.